Good morning, everyone. Today I'm going to talk about another very important physical quantity in physics, torque, designated by tau. That's a Greek. So first of all, let me give you an introduction to torque. Torque is a rotational force that causes an object to rotate around its axis, around an axis. Or sometimes we call this rotational axis or pivot point. This is pretty much similar to force in linear motion. Here I have included two diagrams to give you an examples, right? So when you replace your tire, you apply a force on wrench to rotate the nuts and bolts. That is also torque. When you enter your physics department, you open the door, you are applying a force on the door. So that is also another example for torque. So how do you define the term torque? Torque is a product of force F and applied at a distance r from pivot point and the angle at which the force is applied. So therefore we can combine everything together to find out an equation or formula for torque. Therefore tau equals to force times F times r times sine theta. As I told you earlier, tau is the torque measured in Newton meters. Since torque is physical quantity, it should have to have a unit. The unit is Newton meters. The force, the applied force measured in newtons, that is SI units of Newton, the force. And the R, sometimes we call the lever arm or the momentum, usually measured in meters. Theta is the angle between the force and the lever arm, usually measured in radians, right? So here you can see that this is the force, the perpendicular to the wrench. So this is the pivot point and this is the direction of torque, and this is r is the distance from the pivot point to the force. Okay. Since torque is a vector quantity. What do you mean by a vector? The vector has a magnitude and the direction. Therefore, torque also has a magnitude as well as a direction. Therefore, how do you find out the direction of torque? That is very, very important, right? So, the direction of torque is determined by the right hand rule. First of all, let's see what's the right hand rule. When you curl your fingers in the direction of the force and your thumb points the direction of the rotation, that is the direction of the torque. That's how you get the direction of torque. Since I told you torque is a vector quantity and the physical quantity, and what is the units of torque? Torque measured in Newton meters. Therefore, SI unit, according to the international system of units, sometimes we call SI units. According to the SI units system, the torque measured in Newton meters. Right? But don't confuse this unit with units of force. Force also measured in Newton meters, or we call a special name joules. But here Newton meter is not joules. This is the Newton meter which we use to measure the physical quantity torque. Okay, there's the relationship between the lever arm and the torque. Before you move on, you gotta understand what is the relationship between the lever arm and the torque. Otherwise, if you don't understand properly what is the physical meaning behind this, it will be so difficult to solve problems. Okay, the lever arm, sometimes we call the momentum, is the perpendicular distance from the axis of rotation to the line of the action of force. Therefore, you can see that this green arrow shows you the applied force. If I extend using a dotted line like that, that is the line of action of force. You can see this is the pivot point. So when you measure the distance, perpendicular distance from the pivot point to the line of action, that gives you the length of the moment arm or the lever arm. Therefore, how do you mathematically calculate the torque? The torque can be calculated using this formula, that is tau equals F times R times sine theta. Here you got to understand that the theta is the angle between the force and the lever arm. Once you have force and the length of the lever arm and theta, you can use this formula to calculate the torque. That is how you calculate the torque, the formula. Okay. Therefore, balancing torque is very important. What do you mean by balancing torques? Right? In a rotation, if you have a system, right? Let's assume that that system is rotating, right? System is achieved to an equilibrium when the counterclockwise torques equals to the clockwise torque. Right? That kind of system we call the system is at equilibrium. Therefore, why do we need torque? What are the applications of this torque? That is very important. The first application is the mechanical system. You can apply torques to analyze the mechanical system or understanding and design the various mechanical systems such as engines, gears and pulleys. Then in biomechanics, torque is a crucial in understanding human and animal movements. If you rotate your arm, right, around your joint, right, understanding these concepts related with torque. Therefore, in biomechanics, you can use torque. And physics. Torque plays very important role in various areas of physics, such as rotational motion, the angular momentum, and the behavior of rigid bodies. To conclude this section, so torque is, you should understand that torque is a fundamental physical concept in physics as well as in engineering, and more than that, that's the everyday life. It helps us to understand how forces affect in rotational motion, and very important to analyzing and designing systems that involves turning, rotating, twisting, pivoting. Right? By saying that, I would like to conclude this special topic. Thank you.